Okay, Cappuccino, here is problem number 16. I have already copied down, or written rather, because the problem's in words. I've written a triangle. I've drawn a triangle. So the information in the book is in a triangle, ABC, ABC. AB is X, AC is X plus 1, and angle BAC is 60 degrees. So I've labeled that. And then they tell me the area of the triangle is 14 root 3. Okay, we do not know if this is a right triangle, so we're going to assume it's not a right triangle. So if it's not a right triangle and I know the area, then I can use the area formula to help find missing parts of it. Okay, so here is my area of a triangle. So I'm going to copy that down. Area of a triangle is equal to 1/2 AB sine C. Okay, so C would be the angle in between the two sides, A and B. So here's going to be my two sides. So let's go ahead and fill in everything we know. I know the area is 14 root 3. So I have 1/2 times side A is X, side B is X plus 1, and sine of 60 degrees. Okay, if this was a no calculator test, we could actually figure out what the sine of 60 is using our unit circle. But guess what? We get to use our calculator. So I'm ready to get x by itself here, I think. So what I want to do is I want to get these x's by themselves. So I'm going to divide both sides of the equation by 1/2 and sine 60. So I'm going to have 14 root 3 divided by 1/2. I'll change that to 0.5 just to make my life easier. Otherwise, I could just multiply by 2. Actually, that would be easier. I could just multiply 14 root 3 by 2. But I didn't. I already wrote this. So too bad. All right, so sine 60. Okay, that's equal to x times x plus 1. Okay, so I'm trying to isolate my variables. So let's go ahead and see what this gets me. So fire up my calculator. And I get 14 square root of 3 divided by, use parentheses, 0.5 times sine 60. And I get 56. Wow, that came out nice. So 56 is equal to x times x plus 1. So notice this is going to be a quadratic. If I distribute this, I get 56 is equal to x squared plus x. Okay, in order to solve a quadratic, I need to set it equal to 0, or I can just use technology. Okay, it is possible to actually factor this and do this without technology. So I kind of feel like doing that. So just to show you the old-fashioned way with that, without the technology, I would subtract my 56 from both sides. And now if I'm going to factor this, I need two numbers that multiply to 56, but subtract to 1, because one of them is going to be positive and one's going to be negative. And I happen to know 7 times 8 is 56, 5, 6, 7, 8. And in order to get a negative here, one of them has to be negative, and I want the smaller number to be negative, the bigger number to be positive. So if I factorize that, I get x minus 7 times x plus 8, and you could check that. You could check that, and you would see that that multiplies back out to x squared plus x minus 56. And then if I solve this, I get x equals 7 and x equals negative 8. Okay, looking at our triangle, only one of these answers makes sense. Since this is the side of a triangle, it's got to be the positive one. So we're going to go with the answer x equals 7. We're going to throw out the negative one. That one doesn't make any sense. Okay, we also could have done this on our graphing calculator. We could have gone to y equals, and we could have typed in x squared plus x. Or we could have typed in this one. There's like so many ways we could have done this. There's like a million ways. So if I do x squared plus x, and I want to know when does that equal 56? So if we just go back up to the very beginning of this, and then I graph it, there's my parabola, and there goes my line across. I don't care about the negative answer, the intersection that has a negative x value. I only care about the one that's positive. I could zoom in on this, make it a little bit nicer to see. Do. All right, so there's the intersection we want. So second, calculate, and I want intersection, and I'm going to go a little closer to it. First curve, enter. Second curve, enter. Guess, enter. And look at that, x equals 7. It says it right there. All right, so a couple ways we could have done this problem. So using technology or the old-fashioned way, factorizing. All right, so now that I have that, I can go, I'm going to take that back up here, and I'm going to fill in what I know. I know now this is 7, and 7 plus 1 is 8, but I need the whole perimeter. So I still need the other side here. I still know this is 60 degrees, but I still need to know this side. I'm going to call that C, and now I'm going to use the cosine rule. Okay, so this got me started, and now I need to find this. So C squared is equal to a squared plus b squared minus 2ab cosine of c, which is going to be the 60. So c squared is equal to 7 squared plus 8 squared minus 2 times 7 times 8 times cosine of 60. And I can just throw that all into my calculator. And so 7 squared plus 8 squared minus 2 times 7 times 8 cosine 60. And so c squared is 57. So c is going to be equal to the square root of 57. So now my perimeter, I'm ready to do my perimeter. The perimeter of the triangle is going to be 7 plus 8 plus square root of 57. So I am going to take the square root of 57, so raised to the 0.5 exponent. That gives me the square root of 57, plus 7 plus 8 gives me 22.5. So my perimeter ends up being 22.5 centimeters at 2, 3 significant figures. Bam! That was number 16.